So we're coming back and we're continuing to talk about voltage and electric potential, and I remembered that I went back and I looked, and there's no negative in that equation. There is a negative in the gravitational equation, but not in the electric equation. So when we're talking about gravity, there's a negative in there, but not here. Okay, so what this means is if I have a positive charge, right now, if I think about it, here I've got a positive charge, here I've got a negative charge. If I've got a positive charge that's in this position, it's going to want to run away from Q1 and it's going to want to run towards Q2. So if I take the positive charge and move it from this point to this point, it's going to lose potential energy and it's going to gain kinetic energy. Okay? Similarly, if I take a negative charge, the negative charge, if I put a negative charge here, there's no way it wants to move to this point. It wants to get closer to this charge, further away from this charge, so it's going to cruise this way. So what I say is that the change in voltage from A to B is going to be 714 volts minus 270 volts, which is going to be well, I should do from B to A, so it should be other way around. Negative 270 volts minus 714 volts. So if I've got negative 270 minus 714, I get negative 984 volts. And that's the potential difference. So suppose I took a now if I want to go back, I have this equation, PE equals Q delta V. So suppose I take a proton, and the proton has a Q of positive 1.6 times 10 to the negative 19th coulombs. Well, the potential energy of that proton is going to be 1.6 times 10 to the negative 19th coulombs times negative 984 volts. And this is where this is kind of where units really break down. If I was a better physics teacher, I would force you guys to go through and do all of the units. But I'm just going to say Coulomb volts is going to be, it's a potential energy, so it's going to be joules. So it's going to be negative 1.57 times 10 to the negative 16th joules of energy. I'm going to put the... So a proton moving from point A to point B is going to go from a voltage of 714 volts to negative 270 volts. So it's going to go through a change of it's going to change negative 984 volts. And so it's going to lose negative 1.57 times 10 to the negative 16th joules of energy. And now suppose we just let it go fly free, it's going to gain a kinetic energy of 1.57 times 10 to the negative 16th joules. So where did that energy go? Well, if I'm just letting the proton fly from one point to another point, it's going to gain 1.57 times 10 to the negative 16th joules of energy. And I plug that into Ke equals 1/2 mv squared. And so I have my V is going to be the square root of 2 times the kinetic energy divided by the mass. And so I'm going to have square root of 2 times 1.57 times 10 to the negative 16th joules divided by the mass of a proton. So mass of a proton is 1.67 times 10 to the negative 27th kilograms. And so we're going to get 2 times my answer, let's see, 2 times negative my answer divided by 1.67 times 10 to the negative 27th. We're going to get 4.3 times 10 to the 5th meters per second. And now just a quick note, because we're dealing with this. So I'm going to say that this proton, if I just let a proton fly from point A to point B, when it gets to point B, it's going to be traveling at 4.3 times 10 to the 5th meters per second. Now, quick note. The speed of light is 3 times 10 to the 8th meters per second. If you are within about 1% of this speed, go talk Okay, so quick note, the speed of light is 3 times 10 to the 8th meters per second. If you're within about 1% of this speed, you can't use this equation anymore. You gotta go talk with Einstein and get his modified equations, which is relativity. So 1% of the speed of light is about 3 times 10 to the 6th, and so I'm at about 0.15% of C. So I'm okay with the example that I gave right there. Okay, so basically what we're doing is we're talking about voltage and electric potential, figuring out the potential at one point, the potential at a different point, finding the potential difference between them, and then finding the change in potential energy. And that's sort of the offshoot of what I'm talking about right now.